So this should be kind of where we were. Let me see if I zoom in on this, if this gives us a better view of some of the details. That's about how far in I can go. Yeah, it's a little better. Just a little better. All right. So let's first of all see how you get a new page, right? So in this program, it's a little different. I mean, you don't have a new page. I'm at the end of the page. I gotta have another place to put stuff. You just need to click on the bottom of the current page on one of those guys, and all of a sudden, bing, bang, bada, boom, it says, okay, you need a new page. All right, so as soon as you start filling content in, or your cursor moves down to the bottom of this page, it'll just automatically feed you a new page. And if for some reason I don't start typing anything here right away, and I go back up to the first page, the page will disappear. It'll take it away. I say, oh, you weren't serious. You really didn't want a new page. Okay. So if you want to keep the new page, you got to type something. Right? You have to give it some indication that you needed that new page. Okay. So let's do this. Let's take a look at a calculation. All right, let's just make something up, something fun. All right, so let's do capital Y. We haven't used that yet, and we're going to be defining it, so we want to use that equals. Okay. And when you use the definition equal sign, this is something that you should be aware of. I mean, in algebra, you can have big expressions on the left and big expressions on the right. When you're using the definition equals, you don't want big expressions on the left, right? You're defining a variable, or you're maybe defining a function or something. You're not defining an expression. Okay, you don't define an algebraic expression and define it. You'll calculate an algebraic expression, but you don't define an algebraic expression. So y is the variable. We're going to define it, and let's say it's going to be a cubed minus a squared plus 3a over square root a 5 plus 76 times a. Okay, something like that. All right, so just get used to writing expressions. Remember, the space key is an important feature of MathCAD. It moves the cursor, it selects different parts of things. So let's see, y equals a cubed minus a squared. Yeah, it comes out pretty easily. Now, let's see. Let's just do this. Let's say I just put in the a squared here, and then I have to put in the plus 3a. If I forget to move my cursor down and I just start it with the plus, it's going to be part of the exponent, right? Okay, so that's not what I want. If I hit the space bar once, it's still up here. You can't see it, but it's selected the 2. If you do it with me, you'll see it. Hit it again, and then it's, okay, cursor's down, and if I do plus, it wants to put this in parentheses, okay? That's not what I want, because then this minus sign is going to apply to everything in the parentheses. That's not what I want. Occasionally, well, now what do? So let's undo that. hit the space bar again so that you're selecting now that has this whole expression selected. And then plus just goes on as a new term. Or alternatively, if you're up here in the exponent, get the cursor there, you can just use the right arrow key. Okay? So whichever is easier for you. If your thumb is better than your finger reaching over, it's up to you which way you like it better, right? I like to hit the space bar, but I have to hit it a couple times, but that's no big deal. All right, so 3 times A. Now remember, you got to put the multiplication in, right? You can't just type 3A. And then I want that whole thing divided by. Right? And now, let's say I did the A over 5. And then I'm like, oh, I've got to do the square root, right? So if I didn't put the square root in first, there's no problem, right? If I hit the space bar and do this, and then I want to put the square root sign in, it does it that way because the cursor was on the right of the selection, okay? So it's going to put the square root sign to the right of what I had selected. So let's undo that. It's not what I want. Okay, it's not what I want. I need to make sure that my cursor is on the left, but I want to make sure if I did it now, the square root would just go over the A. Okay? Well, I don't want that. So I want to select the entire expression here, but the cursor on the left. And now I hit, and it does what I want, okay? So there's some of the little nuances that you just need to become aware of. You have to make sure you know how to make the thing sing and dance, right? And then I can move my cursor. Now here, this isn't important, because this will drive you crazy. You know, here's where I was just a second ago. Okay, I had this. And now I want to get over here. So you say, all right, I like to hit the arrow key. Well, the arrow key is going to move you one step at a time to the right. Okay, so you got to hit it a lot of times. All right, so there, your mouse might be a better option at that point to get it over there. And you can go in and use your mouse and select things with your mouse if you like to. So plus 76. Okay. And now, what's the problem with that? Yeah, it's under the radical. I didn't want it to be under the radical. Okay, okay. So I got to make sure I have now the whole radical expression is selected. Okay, and you can see the little gray selection box right on your screen. Right? You can't see it up here, but if you're doing this with me, you can see. Now I can put 76 times A. So, you know, you're just going to have to play with it a little bit to get used to the way to build equations. But it's pretty easy. It's not too bad, right, once you get used to it. Now, here's something you're often going to see. What is that red box? Right? Well, click on it. It tells you this variable is undefined. I've never told the program what A is. I have no idea what A is. So check that the label is set correctly. Do you really want it to be A? Right? Well, first, if I'm using A, what should I do before I use a new variable? What did I teach you last time?
So you want to set the definition with the permanent?
The global equal. I could do that. I could do that. But what do I need to check even before that? Yeah, make sure it's not a unit that's already defined. Make sure little a isn't already defined by the program, right? Well, clearly it's not because it's saying it's undefined. But still, I should check. Just get in the habit. A, and now I'm going to ask equal, right? I ask equal. Just a regular equal keyboard sign. And it says, oh, what is it? And I say, okay, it's not previously defined. It's undefined. That means I can use it, okay? And so now let's say A equals 3.75. Try it again.
Is there a specific
equals 3.75. I had to use the define equals. I had to use the define equals. Okay, and now the red box goes away because now the expression is able to be calculated because the A has been defined. That expression has meaning now. Okay, and now you've got two ways to see the result of that calculation. You can either put the cursor over here on the far right and just hit the ask equal sign, or you can type capital Y ask equals somewhere else on the document, either to the right or below where Y is being defined. Okay? And it is amazing, right? It's a very handy, just that much is handy, right? Just that much is handy. Okay? Yeah. Homework will be so much easier now, right? Yes.
Not now. I know we can do it.
Yes,
it's harder.
Now, here is a very valuable life lesson. This is a paradigm issue. This thing is a tool. Tools are great, but tools have limitations. And so it's up to you, the human element, to know when the tool is being pushed beyond its limitations. But you can only know that if you know what the tool is trying to do, right? And you can tell if it's not working, which means you got to know the math a little manually before you just go into this kind of black box thing that does all this stuff for you. So it's always good to understand. Black boxes are great, but it's nice to know what's in them and how they work a little bit before you just trust them too much, right? Just trusting them too much is not necessarily a good idea. So now there's another way we can do this. This is an algebra expression. And if I wanted to change the value of A that gets used in this equation to some other value, I'd have to go back up to the statement where A is defined, and I would change it. Right, so let me first go in here. There's the result. And I say, oh, it's not 3.75, it's 375. Right, isn't that nice? Okay. But to change the expression here, I need to go back somewhere else on the document where I defined A, okay, and change its definition. Right. All right. Put your cursor inside here. Go up to Math Formatting, and now just like in Excel, I can format the display of the result. Right? I have control over how it gets displayed. So here, just like in Excel, I had general and numeric and decimal places and scientific and all that stuff. Well, there's the list of ways numbers can be displayed. General, which basically means the program chooses for you, okay, which is the default. Then I can say, well, I want to show it as a decimal, and then I can choose how many decimal places to show. I want to show it as scientific notation, I want to show it in engineering format, or I want to show it as a percentage. Okay? Very similar to Excel. Right? So let's say I wanted to, now it's shown as scientific notation, right? And let's do this first. See here, right below the drop-down list for the style of display is the number of decimal places to show. So I can either click the up-down buttons to increase or decrease the number of decimal places shown, or I can drop down the list and it gives me, a choice of how many decimal places to show. And then below that is whether I want to show trailing zeros or not. If you get to the point where the number is just zeros ever after 5 decimal points, it's just zeros ever after, maybe you don't want to show that, maybe you do. It depends. Right? So you can say, all right, hide zeros, trailing zeros, or not. Okay. So let's go in here. Let's set this as a decimal. All right, there we go. And then I don't want to show that many decimal points. Let's see, I'll just show 1. Okay. So there, I get to control how I display the result. Okay. I can also do this. If this is an important result, right? And I have a palette of colors that I can choose. I can choose any fill color that I want for that. So I can highlight important results, right? So maybe you have, just like in Excel, I'm going to tell you, use color. Certain colors for intermediate results that are kind of important. Another color for final results that are like the big ticket item, the take-home message. So those are some things that you can do. So all this formatting, you can choose the font, you can choose the size of the font, you can choose the color of the font. Have all the formatting capabilities here. Okay. All right. Now, here's the other way you can do this. First of all, if I put my cursor inside the box, I get the selection indicator around the box. You see that? This is one way of working with boxes of either math or text. I can go inside the box. This is just like in a Word document. I can also drag across the box from outside, and it selects the box, and it's a different kind of thing. Now I've selected the whole box. Right? And notice I didn't have to drag around the box. My cursor just went through it. If I touched it, I selected it. Right? And you can use that to select multiple boxes. Now it treats this as a big entity. Okay, one big entity. Go back to the Math tab, and I can copy this thing, and then I can paste. And I get a copy and a paste. I can turn off the color on this one. Right, make it go back to no color. And then what I want to show you is I'm going to change the variable to A1 instead of A. So everywhere I have an A, I'm going to change it to A1. So we don't get the program confused by reusing the... So now I have a function. And let's see, let me not ask the question. I don't want to ask yet what the result is. That's going to take away that red box. Okay. I'm not asking for any information. I've just defined a function. Y is a function of A1. Capital Y is a function of A1. Okay? This is an algebra expression. This is a function expression. Right? Here, the variables need to be defined. The values of any variables used in an algebraic expression need to be defined in some other part of the spreadsheet, some other line, some other place, or another equation that calculates it, okay, whichever. But somewhere else on the spreadsheet, I need to define what A is, and then it'll use it in here and calculate. Here, once I've defined the function, I just put it in the argument. I just put the argument in here, what I want to use for A1, right? That's the value of the function expression. Whatever number goes inside the parentheses, the argument of the function, well, it says, all right, anywhere in the function that shows up, I use that number.
You have multiple?
Let's do it. Let's do it. You're reading my mind. That's exactly right, okay? So first, let's just change this to the 375, and you'll see that it should give the same results that we got before, right? So it's just a different way of working. And then we can do this. Let's copy this again. All right, we'll copy and paste, and then we'll modify, which in itself is just very handy. I don't have to type that whole thing again. So paste. And then let's change, let's make A1 just like Excel, comma B1, comma C1, right? Arguments are separated by commas, just like functions in Excel, right? We always have the parentheses after a function name, and then we have the arguments of the function, they're all separated by commas. It's the same thing here, okay? And let's make this a B1, we'll make this a C1. And we'll make this down here a C1. Okay? So I now have a new function of 3 variables. Okay? And then if I want to know any particular value, y of 3.75, comma, 6.23, comma, 8. All right, so A1 is 3.75, B1 is 6.23, C is 8, equals, there you go.
Wow.
Okay? All right, so function symbolism is acceptable and is preferable depending on what you're doing, right? You choose whether you want to show it in algebra format or function format. It just depends on you, you choose, okay? You choose. There's certain advantages to each one. Depends on what you're doing. You just need to be aware that the program can work like this, okay? And then it may be the case, let's copy this expression, copy, paste, and then I'm going to put my cursor here on the left until it selects the whole thing, and then I'm going to backspace. Oh, I didn't want to backspace that. I'm going to delete that. Let's see. Go here. Okay. Delete and control equal. Control equal. Right?
This is the one that's just decorative.
This is just decorative. It just is showing an equal sign. This thing doesn't calculate anything. Okay? It's just display, right? That's a symbolic equal sign. It's not active. This is our define equal sign. I'm defining the function. This is my ask equal sign, where I'm asking it to calculate. This is the symbolic equal sign. It's bold. Okay, it's bold. Okay. Yeah, so that's really the only difference. Okay. So little nuances that you need to be aware of, because if you type the wrong one and your thing isn't working, you may just miss something that simple, and it can drive you crazy. Okay. Drive you nuts. All right. Another nice feature. G of a, let's see, let's do this. Then I don't want to do it. Let's see. G of D1 comma F1. How about that? Okay. Going to define a new function, but the new function has some things that are common to the old function, like the numerator. Copy, paste, and this now I can edit as a D1. This can be F1. This can be a D1, and then divided by 3 times D1 squared. All right, so you can borrow from previously typed equations and just copy out pieces that you might need for the next expression. Just modify. Instead of typing it all over again, if something is close to what you need, just copy the piece that you need. All right, paste and then modify. All right, which can be a very handy time saver. And now that's a live calculation again. And it doesn't matter that I haven't defined D1 or F1 in the document anyplace. It doesn't care because it expects me to define those within the arguments when I want them, okay? So until I need them, it's not going to flag me with a red box. If I had written this as an algebraic expression, just G equals this, then it would say, okay, what's D1, what's F1? You haven't defined it anywhere yet. Right? It would flag me with that red box. All right, so let's see, what else can we do here? Let's change these to subscripts. D1, F subscript 1, okay? And then this is D subscript. Now, you can hit the subscript button each time you want to make a subscript, or you can use the hotkey, which is Control hyphen, and it will do the same thing, right? So if you don't want to keep using your mouse to go up to the ribbon, Control hyphen, and that gives you a subscript. And a subscript is nothing more than a part of the name. The one doesn't get used in any kind of calculation. It's just, you could put a letter in there, right? You could put a word in there, right? It doesn't have to be a number. It can be anything. It's just part of the name of a variable, a subscript.
So how's it different than A1?
This here,
Yeah.
the program sees these differently. They're different variables.
But
This one here doesn't get used as calculations. It's just a part of the name. I could have called this AZ. I could have called it any combination of letters, okay? I could have called it ABC, right? And that's a variable name because I'm not putting any operator between them, right? It's just a collection of letters that must be, program says, oh, that's the name of something. You want to name something that.
so A1 is obviously the program will be different than A subscript 1, but both are the same kind of thing, right?
Yeah, they're both just variables. It's just that the program will see them as different. You can define them to have different values, and there's no conflict, right? Uppercase, lowercase makes a difference. If I just change that from a lowercase a to an uppercase A1, that's a different variable name. The program will see that differently, okay? So it's a good idea as you're developing a document. It's a very good idea to either have a piece of paper and a pen or another document where you keep a variable list. As you define a variable for a document, write it down somewhere and have a collection of all the variables that you've defined for the document in some easy to see place where all the variables will show up. So you don't have to go through 7 pages and look for them all. They're all in one place, either in a separate document or even you could put them in this document. Okay. You could have a variable definition section, which is a very common thing in technical papers. Okay. But it just prevents you from redefining a variable twice. You forget that you've already defined it, or trying to use the same variable name for 2 different things. That'll really screw you up. Okay. So anyway, that's just a tip for when you're developing papers. Now there is, well, let's do another little thing here. Okay, trig, but you the argument of a trig function is an angle. And you got to make sure you put the units that you're measuring the angle in. This is 36 degrees, which is different than the sine of 36 radians. Okay? There are different ways of expressing angles, and angle measures need to have units so that the trig function knows what you intend. Okay? And then you can do this. Okay, so 36 degrees equals, I'm asking what it equals. And it's saying it's 0.628. I say, well, what is that? Well, in the physical sciences, radians is just kind of assumed as the foundation. So when you type in the units radians and the number doesn't change, that's the 0.628 was radians. It just wasn't showing the units. So with angles, it's just kind of common fare in sciences that if an angle measure doesn't have explicitly some other units showing, you assume it's radians. It's the most natural. To us, natural is degrees, but degrees are kind of man-made, concocted. You break a circle up into 360 equal parts. What is that? Right? Whereas radians is more fundamental. An angle measured in radians is directly related to the radius of the circle. Okay, so anyway. So it just did a conversion from degrees to radians. Okay, there's that the units capability and the ability to do conversions, and it will it'll do sine, cosine, tangent, cosecant. All the trig functions are in here, no problem. Okay. All right, let's do this. Okay, so index numbers look like subscripts in terms of the way they appear in the document. And this is recorded, right? I'll send out the link to the recording. Okay, great. But the program uses index numbers differently. You remember index numbers? Maybe you do, I don't know. Let's see, let's talk about them. First of all, let's define an index number. An index number can be any letter. I is well, let's not use I. Let's use K. K is a very common index number. We use things like this in stats. We did the sum of A sub K, and K goes from 1 to some other. Remember we had the summation symbol. Something like that. So index number, right? And an index number is usually an integer, okay? And in the program, we're going to define an index number. So K, if we're going to use it as an index number, needs to be defined. So K equals definition. And now index numbers can go from 0 to 1 to 2 to 3, or 1 to 2 to 3. Where they start can be different, okay? They can even start at negative 100 or something, but let's do the more common things. So let's say it starts at 0, okay? 0, comma, 1, 50. I just defined K as an index number that goes from 0 to 50 in step size of 1. I could define it as a step size of 2 or a step size of 0.1, but index numbers usually go as integers, but I have the ability to define them in any step size I want. Just like in Excel, where we made a column of numbers and we had the spacing between the numbers and we could adjust the space size, the step size, right? But this is a lot more compact, right? This is a nice little expression here. And if I wanted to do this, I ask what K equals. K equals a, let's do this. That's called a vector. That's a vector. It looks just like the column we created in Excel, right? There's a column of numbers that goes from 0 to 50 with step size of 1. There it is, right? So this is the equivalent of making our column of numbers in Excel that we're then going to use for some purpose, either for graphing or for calculating stuff. Okay. And this ... the ellipsis here says it goes further than it shows, right? Because it can get very long. But if you click in here, you can see it says it goes all the way to 50. There are 50 elements, okay? And if I wanted to do this, I could say 0 and 0.1, and then the K now goes from 0 to 50 in step sizes of 0.1. Right? So this vector is now much longer, okay, but it goes in these step sizes here. Right? Now, the contents of this vector are, what I just defined over here. This is the content of the vector. If I click on the vector, notice these numbers along the edge. The first element in the vector starts numbering with 0. The second number in the vector is element number 1. Seems odd, okay, but this is kind of standard. The third element in the vector is number 2. Okay, so I've got the value of the element in the vector, and then I've got the location of the element in the vector. These are index numbers that tell me the position of an element in the vector. That's the typical use for index numbers. So tell me the position of an element in a vector or a matrix. All right? The program allows me to change the starting number, the starting index number.
Okay, so this is just a really nitpicky language question.
Mm-hmm.
But if you were to ask us, say, like, what is the position of 0.2, would we say it's the third index number, or that it's at position 2?
It's at index number 2.
Okay. Okay,
index number 2. Okay, and somewhere we're going to need to be able to define something here. Go to calculation, and notice here on this origin button. That button is where I tell the program how I want to number elements in a vector. Do I want to start numbering with 0, or do I want to start numbering with 1? Okay, and in mathematics, it can be beneficial to do it one way or the other depending on what you're doing. Okay, so right now I've got my first element numbered 0 because that's what's chosen up here in the document. I can change it to 1. And I go back in here. Why didn't it change?
It's not doing it for me.
It's not changing. It should change. Here, let's do this. Let's start fresh. There. just retype it, okay? And now the first element in the vector is number 1. The index numbers start with 1, okay? All right, so you get to choose how the index numbers count elements in their position in a vector or matrix, okay? And it can be confusing, so if you're in a document, it ought to be spelled out somewhere, a little statement that tells you that. Okay. So anyway, here are numbers. These numbers form elements in a vector. If I change the spacing to 1, then I have integers as the elements of my vector, and I have index numbers that are integers. And now I have my first element here is 0, but my index number is 1. If I go back to change this to 0, then let's start again. No, still 0. Oh no, this one 0. Now they match. My index numbers and my elements, they match. Okay. So anyway, I have now got a vector which matches my definition of index numbers, and I can use these numbers, these elements here, okay, like this. How about this? Let's do this. Yep.
Real quick before you move on.
Mm-hmm.
So, if you change the origin thing, does that affect like all this, like MathCAD forever, or just
For that document,
or just that?
for that entire document. That's like a global thing.
So it doesn't
Okay,
affect-
so you don't want to be changing that in the middle of the document somewhere. That would be really
So I mean,
confusing.
it won't like change all your pages and all, like all the different ones you have open.
No. It'll only change it in this document, but it'll change it on every page of this document. Okay? Yep. Yeah, other files won't be affected. Other files will remember the way that you said it when you made that file.
So on this one, when we set a global definition, it sets it for untitled and untitled 1 and untitled 2 on the tabs and logic.
Right, so I have another document here which is just a blank sheet, right? So there's a separate one. It hasn't changed that one. There the origin is still at 0.
Okay.
If I go back here and I change this to 1, then I go back here to this one, the origin is still 0. Okay, so it only changes it on the document that you have open and showing on the screen when you make the change. Okay? All right, so K K is now, I'm going to use K as an index number, and as an index number then it needs to be an integer, and I'm choosing to make the indexes start at 0. By definition, I did that here, right? And I'm making sure the program matches that, okay? All right. And then I can do this. First, I'm going to check, okay, I was just about to use capital A as a new variable, but I checked it, and it says that that's already being used. That's an amp, right? That's a physics unit, right? An amp. All right, so I don't want to use capital A. Let's use a capital. Let's use a capital X, right? That shouldn't be anything. Okay, so it's not. X equals. And now go to the matrix tab. And see where it says insert a matrix? Click on this, and then I get to define how many elements I want in a matrix. Okay, so capital X is now going to represent 1, 2, 3, 4, 5, 6 different numbers. And I can choose whatever those numbers are, and I can input them. So let's just type in some numbers here. So let's put in 3, then tab, and then 5, and then tab, and then 36, and then tab, and then 82, and then tab, and then 104, and then tab, and then 250. Okay, so those are 6 numbers that ostensibly have some meaning to my problem. But instead of defining 6 different variables and giving each variable a different value, I can choose to call all of these capital X and put them all in a vector. And now X index number 0 is 3. X index number 1 is 5. X index number 2 is 36. Where now the index number looks like a subscript. It's going to appear down here like it looks like a subscript, but it's really an index number. So here, watch. I'm going to go capital X, and then the keystroke is a right-facing square bracket. Or you can go up to operators on the Math tab, and you can find, here, let me show you where it is in the menu structure. On the Math tab under operators, I can come down here and, let's see, matrix index, okay, matrix index, right? And you can see right here, it shows you what the hotkey combination is. There's just that square bracket, right-facing square bracket, right? So you can either click on that, or you can hit the square bracket, and look, it creates something that looks like a subscript. It's down, lower, and to the right, but it's now an index number. So if I put in 3 there, and then I ask that equals what, it's 82.
Wait, how did you get the little?
I pressed the square right bracket. See, it even shows you right here what it is.
I typed in capital X, but I'm not getting a little square bracket.
Yes, yes.
Oh, that thing.
Yeah.
Yes.
All right, and then X index number 3, right? I'm still going to call it X sub 3 like it was a subscript, but it's not. It's an index number. It's in the same location. It looks like a subscript, but in the program it behaves very differently. It defines the position of some number in a matrix or a vector, right? So I've chosen to let my origin of my vectors start with 0. So this is element 0, element 1, element 2, element 3. And lo and behold, X sub 3 is 82, okay? And so I can use X sub anything from 0 to 5 in any expression. I could use it as an argument of a function that uses X. I could use it in an algebraic expression that uses X. Wherever I have X as a variable, I put in X with some index, some index number, and it's going to pick the appropriate value out of this vector. Okay? All right. So we'll pick up with some matrix things next time. We'll do some more with these index numbers. And then I think we'll be, pretty dangerous when we can start doing some other things. Okay? And we'll show you some calc stuff that it can do. All right. Okay. All right. Hopefully that's helpful. All right. So I would encourage you either today or tomorrow to just go back into this document and just flesh out some of these ideas. Just type some stuff to make it clear. Okay. And practice. Did that work?
Yes.
That's yours.
You just made this like 5% better. Like, there we go.
Thank you, Dr. Kirk.
Yes,
Appreciate it.
thank you.
Thank you very much.
you so much for these.
Yeah, it's much better to be able to be working with something as opposed
It's
to.
really, really helpful to be able to see it so that I can remember it.
Yep, watching is not the same as doing.
Yeah, and then student loan money just came in during class, so
Oh,
I'll
good.
laptop on Monday.
Excellent.
Hooray.
That'll be a happy weekend that you get your new machine.
Yes,
So there, Alex. Yeah, absolutely. Good. I'm glad that came through.
Bye, see you Monday.
Okay.